Hello, my name is Jad Zaytoun. My student number is 215-909-476. This is my solution to problem 2. So I started off the problem by getting my maximum, minimum moment and torques, and those are just from the problem description. I also got my I and my J, my polar moment of inertia and my second moment of area, right here using by just using the inner and outer diameters. Using that, I calculated my maximum and minimum bending stresses and my maximum and minimum torsional stresses. Using that, I calculated the alternating bending stresses and the mean bending stresses, as well as the alternating torsional stress and the alternating mean stress. Using that, I've used the combined loading equation to find the von Mises alternating stress. Just using that equation, got the answer 57.858 megapascals, and then did the same thing for the mean stresses. Found the distortion energy mean stress, which was just through this equation, got 80.297 MPa, and found my max stress, which would just be the mean stress plus the amplitude, which is 138.158 MPa. And that's when I started the actual calculations after I found all my what was needed. So finding the safety factor, A was asking to find the factor of safety guarding against finite life using the Goodman criteria, which is NF is equal to sigma A over the endurance stress plus sigma M over the ultimate stress, all to the -1. And by plugging in everything, I got an answer of 2.65, and therefore the factor of safety against finite life using the Goodman criterion is 2.65. Question B was asking to do the same thing but using the Gerber criteria. So just using the equation given, I plugged in all my variables, which are just the SUT, sigma M, sigma A, SE, and just plugged them all in, and I got an answer of 3.23. Therefore, the factor of safety guarding against finite life using the Gerber criterion is 3.23. Part C was asking to determine the factor of safety guarding against first cycle yielding, and already calculated sigma max up here, which is just basically sigma M plus sigma A, giving me 138.155 MPa. Plugging that into this equation, ny is equal to sy over sigma max, I got a factor of safety against first cycle yielding of 3.76. Part C was asking to plot a fluctuating stress diagram showing with labels the relevant points of the problem, including a safe design boundaries and your load line. It's just my load line here. This is my Goodman line, this is my Gerber line, and then this is the yielding. And what I found was that this is my sigma A, this is my sigma M, and this is the point here. This is where the load line meets the Goodman line with a factor of safety of 2.65. This is where the line meets the Gerber line with a factor of safety of 3.23. This is where it meets the first cycle yielding line, which is a factor of safety of 3.76. Finally, question E asks, if you lack confidence in the data, which criteria, Goodman or Gerber, would you choose for your design? I said I would choose the Goodman criteria, as it is a more conservative estimate, and the factor of safety is lower, and therefore more failure points lay beyond the line and not on top and beneath the line. It doesn't cut through the lines, more so cuts underneath all the failure points.